Okay. Multi-stage events. Don't invent your own symbols. A coin is tossed 3 times. What is the probability that heads appears every single time? I mean, that's whatever. Half times half times half, which is 1 out of 8. That's pretty straightforward. 2008 HSC, question 7. Xena and Gabriel compete in a series of games. The series finishes when one player has won 2 games in any game. So similar to our tennis match that we just did, right? In any game, the probability that Xena wins is 2/3, and the probability that Gabriel wins is 1/3. Part of a tree diagram for the series of this game is shown. Look, I hope that you guys are seeing, booklets in questions in the other booklet, with just my theory questions. They've come up in the HSC. You saw that one with the traffic light question, or the speeding ticket one, and now you've seen it again with this. They're pretty much the same style of question. Once you wrap your head around HSC questions, they're pretty repetitive, which is good for probability. So I would really encourage you to do HSC questions for probability questions. All right, so complete the tree diagram showing the possible outcomes. Well, if Xena wins, then the second game Xena wins is still 2/3, and then Gabriel winning is pretty much, Gabriel winning is 1/3. In the third game, if Xena wins, then there is no third game. If Xena wins the first one and Gabriel wins the second one, then it's again back to 2/3 and 1/3. And I think the same thing here. XG would be 2/3 and 1/3, and then if that's the case, then that would be 2/3 and 1/3. Whereas in this case, if GG wins, then the game is over because they just have to win 2 games. All right, what is the probability that Gabriel wins the series? Well, for Gabriel to win the series, again, easier second time round, right? It's going to be 1/3 times 1/3. So probability that Gabriel wins would be GG plus GXG plus XGG. And then that should just be 1/3 squared plus 1/3 squared times x, which is 2/3, plus 2/3 times 1/3 squared. I'm going to cheat a little bit because I can see the answer, unless he's done a typo. 7/27. All right. Any questions there? Nope. All right. Triple I. What is the probability that 3 games are played in the series? What is the probability that 3 games are played? So that means it has to go to the end. Has to go to the end. 1, 2, 3, 4, 5, 6. Has to go to the end. 3 games are played in the series. Well, that would be the fact that that needs to occur, plus Xena's one, right? Plus G. Okay. All right. So what is the probability that 3 games are played in the series? Of course, that's just going to be probability of XGX, XGG, GXG, and GXX, or you could have gone the probability of 3 games is equal to 1 minus the probability of 2 games. So I could have done 1 minus 1 on 3, 1 on 3. and 2 on 3, 2 on 3. So the probability that GG wins and the probability that XX wins, and then I subtract it from 1, and that should give me 1, 4, 5 out of 9. 1 minus 5 out of 9 is 4 out of 9. Exactly the answer. Do we get that? So you could have done it, like I said, you could have done XGX and added up everything, but just a lot longer for your math. Or you could have thought of it as, it's probably easier for me just to do the opposite. To get to the 3 games, that means you would have done the opposite of winning at 2-game stage. So multi-stage events, they're not too hard either. I might just leave that one for a bit of your own homework, probably the same as this. They're not hard, I promise. I guess we'll try this. Balanced tree diagrams. Yep, should be fine. We'll do that one. I'll leave that one for you guys. Let's go. Let's do that one real quick. Get out of the way. Okay. 2 machines, A and B, produce pens. It is known that 10% of the pens produced by machine A are faulty, and that 5% of the pens produced by machine B are faulty. 1 pen is chosen at random from each machine. 1 is chosen from each machine. So, what is the probability that at least one of the pens is faulty? What is the probability that at least one of the pens is faulty? All right. What are we thinking? What are we thinking of doing? Anyone have any ideas? What is the probability that at least one? So it is known that 10% of the pen.
1 minus the probability of not being faulty.
That's good. So let's go with 1 minus the probability of no pens faulty, which is 1 minus what?
It's going to be 95 for machine A and
Yes.
90 for B, sorry.
I think that logic makes sense. Let's double check it. 1 minus gives you 0.145. Good work. Again, you would say this is similar to the, let's say, that traffic light or speeding ticket question, whatever. Hope you're starting to realize they're pretty much the same. Double I. Anyways, double I. A coin is tossed to select one of the 2 machines. Ugh, who does that? 2 pens. Okay, 2 pens are chosen at random from the selected machine. What is the probability that neither pen is faulty? Okay, wait. A coin is tossed to select one of the 2 machines. So a coin is tossed to select one of the 2 machines. Well, that means if it was a head, you would have gone for, let's say, machine A, and if it was tail, you would have gone for machine B. All right, that's fine. That's not too complicated. The 2 pens are chosen at random from the selected machine. What is the probability that neither pen is faulty? So that means the first pen has to not be faulty in A and not be faulty in A again if it was half and half, or it could have been that, or, okay, I think, right, is my logic right? Let's make sure. A coin is tossed to select one of the 2 machines. So let's say we flipped the coin and we got heads. Right, remember, play the game. And then you got heads, that means you chose machine A, and then you're going to, 2 pens are chosen at random. What is probably that neither pen is faulty? So that means the first pen has to not be faulty, so not faulty, and then the second one has to also not be faulty. So that would be heads, which is half, times not faulty for machine A, 95%, and then times 95 again. Plus machine, if I didn't get ahead, if it was a tail, it would also be a half times 90% times 90%. I guess. I mean, that's my logic at the moment, unless I've missed one particular case where it could have been heads or tails. No, wait, heads. Yeah, that's it. I'm pretty sure that's it. Let's make sure 0.5 times 90% times 90%. Yeah, that's it. Equals 0.8565. So a coin is tossed to select one of the two machines. Well, that's half, like I said, and then it's got to not be faulty, not faulty. Plus, you could have got a tail, which means you would have gone to machine B, and that's a half and half. All right. Any questions there? Are we understanding when to multiply compared to when to add? Is that anyone's question? We understand that. All right, like I said, try this one at your own time. And let me know maybe next week if you're having any issues with it. Early terminating trees. Yeah, I guess we'll try this one. Looks hard. 5 marks, so why not? Let's try that. And what do we got left? Looks algebraic. Looks nice and long. Oh yeah, okay, so these ones are obviously all algebraic. Algebraic questions are all going to be obviously a lot harder because there's no numbers, so you've got to understand them. And then conditional. Good. I would really like to get to conditional today. What time is it? 11:30. We're doing good. Let's go. Let's get this one out of the way. All right. An 8-sided die is marked with numbers 1 to 8. A game is played by rolling the die until an 8 appears on the uppermost face. At this point, the game ends. Using a tree diagram or otherwise, explain why the probability of the game ending before the 4th roll is this. Okay, can someone tell me how this would work? The probability of the game ending before the 4th roll. What are the different cases? Come on. Anouk, what would you say?
Well, you have to roll a 8 on the 3rd roll at the latest.
Yes, correct.
I'm not sure. I'm thinking.
So what needs to happen? What are the different cases? Like I said, like think of it in terms of cases. That what could happen? Explain why the probability of the game ending before the 4th roll cases. So before the 4th roll, that means you could have 1 in the 1st roll. Which is?
Yeah.
Or what could have happened?
2nd roll.
So if you lost the first though, what needs to happen? You got to roll a 7, any of the other 7 numbers out of the 8, but then you got to win the next one.
Okay.
You guys, you're seeing it? Or you got to lose first 2 and then win 3rd. Plus or, and then you got to go 7 over 8. Lose, which is squared, and then times 1 over 8. Done. Double I wouldn't have used a tree diagram. I would have just written pretty much this bit here. First roll you win, lose the first one, lost the first one, whatever you want to write. Maybe don't change your tenses like I do from past, present. Just bad. But anyways, double I. Any questions in I firstly? All right. What is the smallest value of n for which the probability of the game ending before the nth roll is more than 3/4? Why do I feel like that's going to involve a bit of logs, which is fine, but is it going to involve series? Is it going to involve series? We'll find out. All right, what is the smallest value of n for which the probability of the game ending before the nth roll is more than 3/4? All right, so this was before the 4th roll. Let's say if it was the 5th roll, yeah, it's definitely a series question. No, you won't be able to do double I until year 12. Yeah, you won't be able to do double I until year 12. All right, nope, can't do double I. Sorry. We'll call it, I'll have to write HSC. Series and sequences. Once we do that topic, which is our second topic of year 12, it's the only topic that doesn't involve calculus in year 12. Everything else is going to have calculus. But this is the only one that doesn't. It's part of patterns and stuff like that. So there will be a pattern occurring. If you can see, it's going to go 7, 8, 7, 8 squared, 7, 8 cubed, and so on. And it's always going to be times 1/8. But yeah, we can't do that. And then it would have involved. So it's funny because that question there involves probability, series, and logs. So it's got 3 topics in one. But can't do it just yet. But what I will do, actually, I will quickly do the series, and then I just want to make sure you guys remember your logs. So let me do it, but just you don't need to worry about the way I get the one of the series steps. But most of this will make sense anyway. So probability. Before the nth roll, so before the nth, so end less than the nth roll. So pretty much what we know is it's going to start with 1/8, then it's going to go 7/8 times 1/8, then it's going to go 7/8 squared times 1/8, then we know it's going to go 7/8 cubed times 1/8, and it's just going to keep doing that, right? Dot, 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 until you get to, so if this was 4, this was a power of 2, so 2 less, that's the way we look at it. This is an n, that means you're going to stop at 2 less, so n take away 2. But like I said, you don't need to stress too much about that right now. I'm going to factorize this out. I'm left with 1 plus 7/8 squared plus 7/8 to the power of n take away 2. Next line. I get a, and the formula for a series like this, that's a geometric, is a Rn minus 1 over R minus 1, where a is your first term, so a is just 1. R is your common ratio that this is going up by, which is 7/8. N is the number of terms you'll have. So you've got, think of it like this, you've got 1, 2, 3, 4, all the way to n minus 2. But then you've got also an extra 1 here that has a power of 0 technically. So you have n minus 1 terms, if that makes sense, and then minus 1 over r minus 1. Anyways, equals, you're not stressed, don't stress too much about probably these 2 steps just yet. I'm going to assume we had this, right? Because this line equals to 3/4 is something that you should be able to do. So let me just write that a little bit neater, because that's part of logs and stuff. So we've got 1/8 technically multiplied by 7 over 8 n minus 1 over 7 over 8 minus 1 equals 3/4. All right. So maybe I might make this one a bit smaller. All right. So the first thing, you're trying to solve for n. So the first thing I would do, you see this 7 over 8, take away 1. You would work out what that is, which you know is negative 1 over 8. So negative 1 over 8 and 1 over 8 will cancel out, and you shall have a negative here. Or even better, just bring the negative over to the right-hand side. But because you eventually want to bring them over. So what you're left with at this stage would be 7 over 8 n minus 1 minus 1 equals negative 3/4. Then remember, you're trying to solve for n, so you're going to plus the 1. So then you'll have, let's see if I can fit all this in. Let's come up here. All right, you'll have 7 over 8 n minus 1. And then you're going to do negative 3/4 plus the 1, which is 1/4. Then you're going to get rid of your n minus 1. And how do we do that? What do we do at this stage to both sides?
Log them.
We're going to log them. So then we're going to have a log, and then a power. We can bring our power down. So we're going to have n minus 1 log 7 over 8 equals log 1/4. We're going to divide by this log, so you're left with n minus 1 equals log 1/4 on log 7 over 8. At this stage, you'll plug this into your calculator. Log 1/4 over log 7 over 8, which is 10.3, and then n equals 11.3. Just go back and reread the question. What is it saying? What is the smallest value of n for which this will have no more than 3/4? You're meant to round up, but that's something else we can talk about. But the idea is I didn't make it no more than, because that is at 3/4. So if you can't have any more than 3/4, it's going to be at n equals 12. But don't stress too much about that, because we didn't get too much into the question. I was just trying to emphasize the logs bit. You can see how a topic that we've done will come back, and logs especially, because it's the only topic that you're going to have indices that you need to be able to solve, and it's done via logs. So again, what I did, I just fixed up the denominator. That became negative and 8. 8 and 8 cancel out. The negative, I just brought it to the right hand side. Then you're left with the numerator here. I plus the 1. That became 1/4. At this stage, you want to get rid of your power, so you're going to log both sides. You bring your power down, divide your log, and then just plus the 1. So you should be able to get to that. I can guarantee you'll see one of these style of questions in your prelims, and then of course they'll come up in your trials and in your HSC as well. So you got to know how to solve with logs. Okay, hold on, we're doing all right. Anyone have any questions for this one? Just solving it instead. Okay, all right. I think given the time, we'll have to come back to those ones. Next week, I would really want to get onto some conditional probability. All right. With conditional, so we've got probability of A to B is probability of A. Okay. Probability of A intersection B on probability of B. So the conditional probability So I need you guys to write this. The conditional probability of A occurring given B has occurred is denoted by probability of A occurring given B has occurred. Conditional probability of A occurring given B has occurred is written like this. So that's what conditional probability is, right? So the probability of A occurring given that B has occurred is equal to the probability of A occurring and B occurring over the probability of B occurring. All right, so this intersection sign, which we're going to look at next week, a little bit further, but for now you just need to know that's just the probability of A and B over the probability of B. All right, let's see. I don't know if I would exactly be doing it just like that. Let's have a look. What has he said? Let's make sure. Remove. So he says the steps are: you remove all elements not in B from the sample space. Remove all elements not in B from the event space A, and then you should be able to compute that. So remove all the elements not in B from the sample space. Remove all the elements not in B from the event space, which is here. This is the event space, and this is your sample space. And then you should be able to just compute that. But let's see if we can just do it the way I would think about it. In a certain population, 35% have blue eyes, so let A equal to 35%, in other words. And 15% have blonde hair. 10% have blue eyes and blonde hair. So 10% have A and B. A person is chosen from this population at random. Find the probability that they have blonde hair given that they have blue eyes. A. So maybe it is easier to just follow his one for this particular case. So what you would do, remove all the elements not in B from the sample space. So, so in this case, what do we got? We've got 10% that have blue eyes and blonde hair. So find the probability that they have blonde hair given they have blue eyes. So what you're going to do is take out 10 from 15. 15%. Let me make sure I don't do these wrong either myself. And that becomes 10%. On 24%. Probability of A and B and probability of B. Probability of blonde hair, they have blue eyes. Probability that they have blonde hair, so probability of A conditional on B. They have blue eyes. It's probability of A and B, which would be 10% on probability of B, which would be 15%. No, I'm doing something wrong. That is B. Find the probability that they have blue eyes, given that they have blonde hair. Find the probability that they have blue eyes. They have blue eyes, given that they have blonde hair. So blue eyes, given they have blonde hair. Yes, blonde's 15. So that blue eyes blonde hair. This one is blonde hair. Probability of blonde hair, given that they have blue eyes. The probability of B intersection of A and the probability of A, which becomes 15.
Sam, I think I got it.
Yeah, tell me.
I just got it by accident, but I used that formula.
Yes,
P
yes.
bracket A slash B equals A, the upside down U, B on B.
Yes.
And I did 0.35 equals 0.1 over B, and I solved for B, and I got the answer.
0.35 equals?
0.1 on B, and I got the answer.
Okay, so hold on. Blonde hair. Given they have blue eyes.
I got it by accident, though, so
Yeah,
I'm
I
not
get
sure.
you. I get you. That's fine. So what we're trying to do, the probability of that is 0.1 over 0.35. 0.1, 0.1 over 0.35. So 10% on 35% instead of a 15%. Given that they have blue eyes. Oh, blue eyes is 35%. Oh, I did my math wrong here. PA, 35. Blonde hair. No, but I did blonde hair. Yeah, that's right. Oh, I don't know what I was. Okay, oh, but yeah, I already have it. Oh, good. I'm using the wrong numbers. I didn't realize it was 35. I was using 10% for some reason. All right, all good. Don't stress. Everything's fine. Okay, ready. Find the probability that they have blonde hair given that they have blue eyes. So what we've labeled here is A is blue eyes and B is blonde hair. So if you had to work out the probability of blonde hair given blue eyes, that is the probability, so A, the probability of blonde given blue, which equals to the probability of blonde and blue, blonde and blue. Blonde and blue is 10% over the probability of blue, which is 35%. And that should give you 0.29, right? So 10% on 0.35, yes. B, find the probability that they have blue eyes given they have blonde hair. So that one would be probability of blue eyes, so A, given probability of blonde hair. So blue eyes, given the probability that they have blonde hair. So that becomes, again, the point of the intersection of them having blonde and blue, which is 10%, over the probability of B. So probability of B is blonde haired. So 10% over 15% should give you 0.67. So let me confirm that again. Let me double check that with you guys so you understand. Because as I was thinking, I probably lost a few of you. So probability of A conditional to B is the probability of A occurring with B on the probability of B, or if you had to say probability of B conditional on A, that is the probability of B occurring with A on the probability of A. Right? So if A, it's conditional on A. If it's B, it's conditional on B. Do we get that? Anyone want me to maybe redo this again? And then you can always verify with the Venn diagram because there's the overlap. So I mean, let's see, how would we verify this? In a certain population, 35% have blue, 15 have, okay, so A, what did we label A as? Blue-eyed. Blue is 35%. And B is 15%. And then 10% have both blue and blonde hair. So this is 10% right in there. That means blue only is 5%. That means A only is 25%. And then find the probability that they have blonde hair, given that they have blue eyes. So given that they have blue eyes, what's the probability of them having blonde? Wait, I hate this A and B. A is blue, and B is blonde. That's it. Find the probability that they have. Where am I? Find the probability that they have blonde hair, given they have blue eyes. Find the probability that they have blonde hair, given they have blue eyes. Blonde hair, given that they have blue eyes. Using a Venn diagram, blonde hair. Okay. What would I have done? I would have done, given that they have blue eyes. So you already know they do have blue eyes. So them having blonde hair as well. So this is intersection. This is P, this is P, A, this is P, A, and B. So you would have to say 10% on 15%. So it wouldn't have made a difference. Okay, so for that other one, and then that should be 10 over 35. Yeah, all right, so find the probability that they have blonde hair, given that they have blue eyes. So to verify with a Venn diagram, you guys can see what I've pretty much done here. The intersection is 10%, and then you can work out what they are individually, which means blonde is like 5%. Blue only is 25%, but that's only blue. So, but if they are to have blue eyes, then that would be 35%. And obviously, to verify it, you can tell that the probability of conditional on blue eyes, right? Yeah, the probability of having blonde hair, given they have blue eyes, is 10% that overlaps out of 35. So the 10% that overlaps out of 35. Or what's the probability of them having blue eyes, given that they've got blonde hair, right? Which would be the next bit. Blue eyes, given that they have blonde hair. So again, blue eyes would be 10%, because that's the overlap, given that they've got blonde hair, which is 15%, because 15% have blonde hair. So you could also verify through a Venn diagram, which we're going to look at a little bit more next week. But I just think the formula makes a lot more sense. All right, let's have a look. I guess at another one. I don't have time. Oh, all right, we'll have to leave it there. Let me save this.